సార్ గుడ్ మార్నింగ్ సార్ ధనంజయ సార్ సార్ మీరు వీడియో ఆన్ చేసుకోండి సార్ 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 వీడియో వీడియో అదే ఇక్కడ విజిబుల్ సార్ రావట్లేదు సార్ మీరు వీడియో ఆన్ చేస్తే సార్ మీరు పడుతుంది సార్ shall we start, sir?
Sir, good morning. Good morning.
Good morning.
How are you? Sir, fine, sir.
Good morning, sir.
Good morning. Good morning. Good morning, sir. Good morning. How are you, sir? Fine, sir. Fine. Sir, 2 minutes, sir. Dean is on the way, sir. On the way.
In a connection problem, and
Sir, Dean is on the way, sir, on the way. Just for 2 minutes, sir. 2 minutes. Dean faculty absence. Dean faculty.
Hussein gar Hussein gar, hello.
Sir, sir.
Hussein sir.
Hussein, sir. Sir.
చెప్పండి.
Sir, వచ్చారా? వచ్చారు సార్ లైన్ లో. వెరీ గుడ్. ఇట్లా పెట్టారు. ఉండలే సార్ మాట్లాడినారా? Good morning, everybody. Warm welcome to external expert member of today's YSR, Professor Dhananjay Rao garu, the Professor Department of Geology, Andhra University, Visakhapatnam, and our beloved principal and Dean Faculty of Sciences, Yoga University, Professor K. Krishna Reddy garu, and my dear colleagues Raghu Babu, Sunita, Srinivas Gaur, Jayaraju, and also academic consultants, research scholars, and also students, print electronic media. On the occasion of Vaivavasi of today's Mr. Ravi Ramachandra, Mr. Ramachandra, who is doing PhD under the guidance of Dr. Raghubabu. Previously, he did MSc in the Department of Geology, Yoga University. That he is a regular hard worker and also dedicated nature. After that, he joined PhD under the guidance of Raghubabu. He is a RGNF fellow. He published a number of publications both in Springer as well as in elsewhere. Now I request Ramachandra come over to there and give brief introduction, methodology, and results of your work, and also give the answers to the questions raised by the certificate members. Now I request Ramachandra start. Meeting room. Sir, Dhananjay Rao garu, very sorry. I am changing the formalities of this YYOC due to the meeting with our Honorable Vice Chancellor. At the outset, the Department of Geology is the oldest department from the beginning, inception of the YVU. Before that, it was the PG Center for the erstwhile Sri Venkateswara University. The faculty members are very vibrant and they are doing very good research in spite of limited funding and also resources and proximity to town also far away. So with these adverse conditions, it is really appreciable to the department. All of them are doing extremely good. Today, Dr. Raghubabu took a novel topic for research, and the Mr. Ramchandra, who could be able to complete it successfully within the stipulated period, and he also made significant contribution to the science and technology, and hope this will be formed for other students to carry out research for the in near future also. So he made good publications. There are few queries from adjudicators, and hope you will make this presentation more effectively. And with your permission, before completing the open OOC, I am saying a few words. Sir, please permit me. Dhananjay Rao garu. Sir, thank you. So, it's based on his thesis and the results and everything. We can declare doctorate to him after completing the formalities of Yogi Vamana University administration, sir. So, I congratulate Dr. Raghubabu for guiding him, and also Mr. Ramchandra to confirm the PhD degree soon. Sir, thank you very much, and I will leave now. I am sorry I couldn't stay for a longer period until completion of this open Viva also. I I sincerely appreciate Sir Dhananjay Rao garu for be one of the adjudicator and giving the very positive note of his PhD evaluation. Sir, hope that he will be giving more inputs to our university, and because geology is slowly fading out, sir. People like you has to be revived. This is one of the excellent subject for the environmental and sustainability of the global warming and other things to be studied only based on the geology, other interdisciplinary activity only we can carry out, because our area is having hills, and also we have the lot of minerals, and also the under sedimentations of the water levels are also very low. So we can definitely people like you to be with us in the coming years also. Thank you, sir. Thanking you. I sincerely congratulating Dr. Raghubabu and Ramchandra for his PhD, and also all my colleagues who are in the Department of Geology. So with their dedicated efforts, this department is getting a milestone in the Yogi Vamana University history. Thank you, sir. Thank you very much. Good answer.
Good morning, sir. Good morning to one and all. Today, my final open PhD Viva voice presentation entitled Structural Mapping in Southwestern part of YSR district, Andhra Pradesh for groundwater assessment and mineral exploration by using satellite image and GIS. Next coming slide, chapter setting. Chapter 1, Introduction. Chapter 2, Environmental setting of the study area. Chapter 3, Material and Methodology. Chapter 4, Structural mapping for groundwater assessment. Chapter 5, Structural mapping for mineral exploration. Chapter 6, Summary and conclusion. Next coming slide, chapter 1, Introduction, Research problem, need for groundwater and mineral development technology, previous research work, objective of the study area background, scope of the work, organization of the thesis. Next coming slide, Introduction. Groundwater is the key source for day-to-day existence in both an urban and rural areas, with recently observed infiltration rate decrease due to deforestation and lower rainfall beside the increasing urban development, while the mineral wealth of any region provide the base for industrial development, thus the growth for the capital income of these residents. Present research in attempt to delineate the groundwater and mineral exploration in southwestern part of YSR district for consequent mineral and groundwater status. Structural mapping through remote sensing methods is one of the most effective tools for studying fault framework and the deeply structure of geological region. The present analysis is based on an interactive mapping tool that allows user to map the prospective view of their surface with the traditional two-dimensional map space. Knowledge of geological structure and their topographical relationship structural features, identification of alignment with diagnostic features. The Kadapa Basin is considered an intercontinental sedimentary basin that developed during the breakup of the supercontinent. It is characterized by episodic hydrothermal accumulative events and long-term stratified Kadapa Basin is during the Proterozoic to early Cambrian. The linear features which are fault and fractures give intimation about the mineral and groundwater resources and strong tool for exploration. Many earth scientists have been attracted in linear features of the earth crust since the early period. Remote sensing techniques are providing a means for regional understanding of groundwater and mineral prospecting. Its data provides information on spatial pattern, lithology, geomorphology, structural and groundwater dependent vegetation, etc. The focus of this work is related to linear analysis using remote sensing and GIS techniques to found the area of mineralization and groundwater expectation and accumulation for easy exploitation in YSR Kadapa district. Geological elements are identified to delineate in the landside data to assign the orientation of geological structures using data from geological geomorphological map are prepared by the satellite data and then import the satellite image in a remote sensing tool are verified with the actual data to interpret the lineament orientation. Mineral exploration through structure guide is playing important role through remote sensing and GIS. Mineral exploration has been traditionally based on the application of a variety of prospecting methods, mainly preparation of structural maps and ground survey operatively integrated with exploration basis. The linear characteristics like linear features give intimation about the interior for exploration of mineral and groundwater resources. Next coming slide, the need of the research. The mineral prospecting is the way towards finding financial feasible grouping of mineral and is the primary connection with economic growth. The study approaches to taken to find new mineral locations depend on various variables like the locations, the area of the zone, accessibility and feasibility in the environment. The prospecting of approach to specific mineral and metal requires some information or a theory of how and why mineral happiness in a nature in a specific locations in the world's covering. Increasing demands and competition among the major water using sectors such as agriculture, drinking and industries. A growing concern over how these demands can be effectively equitability and sustainability met innovative water management and allocation policies to promote the economic development and development of village community. Significance of study. The structural map prepared, the present study can be utilized by the Mines and Geology Department for the exploration of new sites mineralization. Mineral prospecting maps prepared in the present study were extracted along the lineament of existing mines sites, hence they can be utilized by mines various. The thematics map prepared can be utilized by government organization for identification of groundwater potential zones. Conjunctive use of surface and groundwater which can increase the efficiency, reliability and the cost effectiveness use. Facilitated effective intersectoral allocations of water, including transfers of water out of agriculture. To study the different thematic maps for the huge process, groundwater and the mineral exploration for sustainable development and economic growth. The study area using remote sensing and GIS various decision making model. Next coming slide, objectives. Preparation of various thematic layers and structural density map, delineation of groundwater prospecting zones by structural mapping, delineation of mineral prospecting zones structural mapping, to explore the new mineralized zone using a satellite image through extracting the structural mapping, to identify the extension of mineralization in the existing mines through the structural mapping, to study prospect zone for groundwater potential zone using decision making model. Slide chapter 2, environmental setting of the study area. Introduction, natural environmental factor of the study area, geology, geomorphology, lineament, slope, soil, climate, rainfall, hydrogeological characteristics to mineralization of the study area, human factor, land cover. This map shows location map. First one, India, Andhra Pradesh, Kadapa district mandal boundary map. Kadapa district I have selected in southwestern part of 9 mandals. 9 mandals like Alingala, Pulivendala, Vemala, Vempalli, Virunapalli, Pellimadi, Chakrapeta, Redpalli and Galavidu mandals. The study area is located into 78 degrees to 79 degrees longitude, east longitude, 13 to 15 degrees north latitude. The entire geographical study area of the district is 2648.72 square kilometers. This study are occupied in southwestern part of YSR district. The Kadapa basin is sedimentary basin of Proterozoic era located in the peninsular India at the close of the Archean era. The large part of the basin was subjected in shallow and sea deposition of sediments such as conglomerate, quartzite, shale, dolomite and limestone took place during the middle Proterozoic period. These sediments are referred to belonging to the Kadapa supergroup. The YSR Kadapa district is underlined means for rock type belong to late Archean or early Proterozoic era, which are succeeded by the rock of the Arvanian age, and both are traversed via dolomite dikes. The essentially rock sequence quartzite and shale and asphalt to quartzite and dolomite with igneous intrusive, conglomerate quartzite, strontiolite and dolomite mudstone checked breccia, quartzite with basic. These rock shots occur in the southwestern part of the YSR Kadapa district. Next coming, this table shows the lithostratigraphic section of Kadapa supergroup. Reference at Navaira Sarata. Supergroup succession divided into 4 groups: Papakdi, Chitravati, Nalamala, and Karnolu. Under my study area, 2 groups: Papakdi and Chitravati. Papakdi group divided into 2 formations: Gulcheru quarters and Vempalli formation. Chitravati group divided into 3 formations: Pulivendala quarters, Tadapatri formation, and Gandikota quarters. These are the different thickness. These are the various lithology. Next coming slide, geology map. This is the entire study area geology map. Geology map procured from the GSI 2002 Hyderabad. The legal unit of study area belonging to Kadapa supergroup. Different lithological formations of Chitravati group. The major igneous mineral found are asbestos varieties, asbestos and textile varieties occur in association with subsequent developed. Other the contact of basic intrusive Vempalli dolomite. The mineral occur in the study area mandals of Kadapa district and serpentine and Proterozoic corporate sediments of Vempalli formations filled by the dolomite silvic. Major part of the occupy lithology, Pulivendala quarters and Vempalli dolomite, Tadapatri shell. Minor amount of the lithology, Turkey limestone. These are the collected field photograph in my study area. First one, sail bed, Malala section near Pulivendala Mandal. Second one, quartzite beds near Vemla. Third one, dolomite individually quartzite succession bed, Panapalli, Lingala Mandal. Next coming slide, geomorphological map. Geomorphology map are useful for analyzing the morphological features of the study area. Morphological features were observed in the Landsat 780 plus imagery and different features like anthropogenic terrain, radiation origin, dike still ridge, fluvial origin, pediment pediment, residual hill, structural origin and water bodies. This is the collected field photograph in the geomorphological related study area. This one, residual hill, Vempalli, Edulakonda Swami temple. This one, pediment near Vemla area. This is structural hill near Chakrapeta. This is Pediplan near Pulivendala. This is fluvial landform near Virpanapalli. This is residual mode and Pediplan near Nuluvidu. This is the ridge near Lakredpalli. This is the dike near Galividu area. This is the entire study area alignment map. In my study area, alignments are categorized into 2 types of alignment: geomorphic alignment and structural alignment. Geomorphic alignment are ridge parallel and scarp parallel. Structural alignment joints, fracture, dikes, and fault. This Google image shows this is the alignment orientation of granitic terrain. This yellow color line shows the alignment directions. Next coming slide, slope. Slope map prepared by the Amsterdam data. In my study area, shows the slope map. Highest slope in greater than 45 degrees. Lowest slope in 0 to 5 degrees. Slope is individual to significant field which can be clarified by a horizontal arrangement of the contours. In the vector form of strictly spaced outline characterized steeper slope and thin contour. Here the slope of steep slope. In raster elevation of slope measured by using the identified maximum size of alternate the rate of each cellular to neighboring cell. Next coming slide, soil map was prepared with the help of the Kadapa district groundwater department. The present study reveals the foremost of soil types like gravelly loamy calcareous, and minor formed by the clay calcareous. The major part of the study area covered by the gravelly loamy soil. Next coming slide, climate and rainfall. This is the study area rainfall graph. In my study area, highest rainfall in 606.16 to 628.80 mm. Lowest rainfall in 515.59 to 538.23 mm. This is the graphical representation of rainfall. I collected 10 years rainfall from district administrative office Kadapa. In my study area, highest rainfall in 2015 to 16, lowest rainfall in 2018 to 19. Next, climate. Kadapa has a hot semi-arid climate characterized by year-round high temperature. It has a recorded of reaching more than 46 degrees Celsius. Summer are especially uncomfortable with the hot and humid condition. During this time, temperature range from minimum 26 degrees, maximum 46 degrees Celsius. During the winter, temperature range from a minimum 25 degrees Celsius to maximum 35 degrees Celsius. This map shows will be a land cover map. Land cover map using satellite data and perform supervised classification in radar imaging software. LULC classified is different features is there for forest land, cropland, barren land, fallow land, wasteland, and water bodies. Majorly, the study area occupied by the agriculture, cropland, and minor part of the water bodies in the study area. Next coming slide, chapter 3, materials and methodology. Data and software use topographic map, satellite data, Landsat 7 plus, field equipment, software use ArcGIS 2.8, data imaging 2014, rockworks, groundwater and mineral exploration, groundwater assessment, structural mapping for mineral exploration. Next comes that topographical map. Topographical map are collected from Survey of India, but nowadays it's available in online also. The whole my study area, Kadapa district, is covered by 12 Survey of India topographies, numbered as 57F14, 57J by 2 to 57J by 15, 57K by 5, and 57K by 9 at a scale of 1:50,000 scale. The maps are geo-referenced and used as a base map in the field. Next slide, data used. Some data used, satellite data, auxiliary data, collateral data. Satellite data is Landsat 7 ATM plus. This data resolution 30-meter resolution from year of 2019. This available data in USGS Search Explorer and proven site also. Auxiliary data collected Survey of India topographics with the scale 1:50,000. This available data in Survey of India. Collateral data, climate, soil, and rainfall, etc. These data available in the groundwater department, Kadapa district complex. I have some equipment used GPS for collecting field latitude and longitude values. So I have some software used for ArcGIS 10.8, radar imaging 2014, and rockworks software. Next coming slide, this is the groundwater identification of groundwater methodology flowchart. Collected in some data, remote sensing data, Landsat SRGM DEM, conventional data, existing map, JS and LBSS means National Bureau of Standard Sites, land use planning map, and collateral data. First one, remote sensing data will to prepare fault and fault density map, geomorphological map, DEM data to prepare slope map, remote sensing data to prepare linear structure and linear density map. Second one, conventional data to prepare geological map and soil map. Collateral data I collected 10 years rainfall data collected in prepared study area rainfall map, and all thematic layers conversion into ArcGIS software and raster conversion, and I went to weighted overlay analysis normalization using ArcGIS software. Finally, I prepared groundwater potential map. This map validated into AEC ROC core map. This AEC ROC are a machine learning program. Next coming slide, mineral prospecting zones, assessment of methodology flowchart. First one, data collection, primary data and secondary data. Primary data, remote sensing data, Landsat 7 ATM plus DEM data. This data to I will prepare geomorphology, slope, limit structure, limit density, dike density, fault density. And secondary data collected to existing mine locations and the survey of proposition, survey of India maps. And I will to prepare geological map. All thematic maps calculated in the density calculated in ArcGIS, and then mineral prospecting map. Finally, lithology, structural control, density based. I prepared final proposed mine locations map. Next coming to chapter 4, structural mapping for groundwater assessment, introduction, groundwater exploration, structural features of the study region, groundwater potential zone assessment, AHP approaches, pairwise comparison matrix, real-time discussion, structural control of groundwater, element and density, dike structure and density, fault structure and density, structural control variation, rainfall, validation and conclusion. Next comes to lineament analysis. Lineaments like lineament features are geologically very important and may provide the way for groundwater exploration. The remote sensing techniques are given further boost to lineament studies through the satellite image. Identification of lineaments become quite easy because of the synoptic view, availability of data in different spectral bands and the respectivity. Lineament density variation to the consequence of tectonic alteration, rock splitting and shearing, mineral and groundwater possibilities. Next coming sir, this map shows the alignment of the study area. This is the road diagram prepared by the alignment orientation and direction. This road diagram prepared in Rockwork software. Next coming to alignment density. This is the entire study area alignment density map. My study area highest alignment is 7.69 to 9.61 km per square kilometer. Low density in 0 to 1.92 km per square kilometer. Next coming to structural control of groundwater. This is alignment and alignment density, dike and dike density, fault and fault density. Dike and fault both compare with the most dominated in the study area, dike structures. This table shows the AHP model approach, AHP analysis, different weight analysis and normal weight. Say, show the this is the lithology wise. This is the criteria. This is the different different criteria. Even the rank to 1 to 8 rank. Different criteria I have referred to geology, geomorphology, fault density, lineament density, soil, slope, land cover, and dike density. This is the final groundwater potential zone map in my study area. The resultant groundwater potential zone map through GIS method and overlay weighted method separated to the study part in 5 classes: poor and very poor, moderate, good and very good zone, contributing to 0 to 78%, 0.78% very poor zone, 14.04% poor zone, 57.79% moderate zone, 26.75% good zone, 0 to 62% very good zone. For validation of the reliability of the concluding result, a good inventory survey of the groundwater potential map validated by selecting 130 wells, duck and bore wells by using AES and ROC curves. This is a machine learning program. Curve with 82% may be conducted on various locations of the study area. Next, coming slide, chapter 4, structural mapping for mineral prospecting, introduction, element and density, lithology, asbestos, varieties, gold, ferropellets, quartz, serpentine, striated and uranium. Next, coming slide, mineral exploration, remote sensing and GIS interpretation are significantly cost-effective techniques in the mineral exploration program. The data interpreted from satellite imagery is analyzed in a GIS software environment and analysis can be made about the classification of mineral occurrences. It can further be used as a guide for similar deposits in the region by identifying the prospecting zones. All these weighted data were integrated to produce the predictive control model that related to mineralization using GIS application. Among such techniques, such analysis is a significant tool in the mineral exploration that has been used by many workers in the execution of the exploration program. The type of composition of mineral determining the spectral response of the rock type. Satellite imagery exhibit tonal variation in linear features in the journal. So, a defined contrast within the background of country rock interpretation of the lineament will provide the understanding of the structural setup of the study area. Next coming slide, asbestos. Asbestos is a mineralization of serpentine zone mineralization. Asbestos are collected in 4 existing mine locations in the asbestos Lingala Pulivendala area. These are the longitude and latitude values. A star symbol shows the existing mine locations. Structural control and density based, I prepared again 4 new asbestos mine locations. Lingala Mandal in Lopakmutula, Ambakpalli 2 sites, and Pulivendala Mandal in Brahmanpalli area. These are the longitude and latitude values. Star mark symbol shows the proposed mine locations. Next coming slide, white varieties. White varieties in my study area occur in vein type deposits. I have collected in 10 existing mine locations in Lingala, Pulivendala, Vemla, Vempal area. These are the longitude and latitude values. Circle symbol shows the existing mine location. Structural control and density based proposed again 6 new white varieties and Lingala mandal in Pidandla, Lopaknutala, Ambakapalli, Vemala mandal in Verpala, Kottapalli, Vempalli mandal in Kattaluru. These are the longitude and latitude values. Star mark shows the existing mine location, proposed mine locations. Next coming slide, gold. I have collected in 4 gold mine locations in Galividu, legal area. These are the longitude and latitude values. Structural control and linear density lithology based. I proposed again 4 new gold mine locations in Veligal, Galividu Mandal, Veligal area. These are the longitude and latitude values. Next coming slide, ferrobelite. Ferrobelite is the address aluminum silicate metal. I have collected in my study area 2 existing mine locations, Chakrapeta, Galividu. These are the longitude and latitude values. Linear structure density lithology based. I proposed again 4 new ferrobelite mine locations. Chakrapeta, Surabi village 2 places. Galividu, Nuluvidu village 2 places. These are the longitude and latitude values. Next coming slide, quartz. Quartz is a silicate metal. I collected in existing mines, 2 existing mines collected in my study area, Chakrapeta, Lakredpalli. These are the longitude and latitude values. Structural control linear density based. I prepared again 2 new quartz mine locations, Chakrapeta, Errakummanapalli, Lakredpalli, Brahman Erragudi. These are the longitude and latitude values. Next coming slide, serpentine. My study area, I collected in 2 existing mine locations in serpentine, Pulivendala and Lingala. These are the longitude and latitude values. Structural control and density based. I prepare again 2 mandals, 2 new mine locations. I proposed Pulivendala mandal in K. Velambarpalli, Lingala mandal in Gunkapalli. These are the longitude and latitude values. Next coming slide, steatite. I have collected in 2 existing mine locations in my study area, steatite mine, Lingala, Pulivendala mandal. These are the longitude and latitude values. Linear structure density based. I prepared again 2 new steatite mine locations, Lingala mandal in Lingala village, Pendlimari mandal in Pangalpalli. These are the longitude and latitude values. Next coming slide, uranium. Uranium is the strata-bound deposits. Strata-bound deposits in study area. I have collected in 3 existing mine locations, Vemla mandal. These are the longitude and latitude values. Structural control density based. I proposed again 3 new uranium mine locations, Vemla mandal, Rachikantapalli, Muppindalapalli, Tummalapalli. These are the longitude and latitude values. This map shows final lineament and density map. This is the highest lineament and lowest lineament. Highest lineament 7.69 to 9.61 km per square kilometers. Low density 0 to 1.92 km per square kilometers. This is the various symbols shows the existing mine location. Different colors. Star symbol shows the proposed mine location. The proposed methodology allows for the automated evaluation of study area with complex geology for identification of mineral concentration above the lithological background. This is achieved by producing the enhanced via background subtraction of the letter as a function of the lithotypes. The identification of lineament density existing mine and distinct geological environment is greatly facilitated and significantly reduce the diversity of possible target of mineral exploration in this study area. This map shows will be lithology and lineament map in my study area. This is the different lithology in my study area. Different color symbol proposed by location study area. Various symbol show the existing mine locations. The study has verified the importance of lineament mapping to estimate the mineral exploration of a typical basement terrain involving the integration of remote sensing and GIS techniques. This involved the interpretation of GIS analysis of lineament and lithology map paper. The result of the analyzed lineament indicated that the area of numerous long and short features good structural trend and mainly in the north, south and east-west direction. The cross-cutting lineament are relatively high in areas around the central northeast and the southwest part of my study area. But relatively low in the other areas of the zone of high element intersection, density and feasible zone for mineral proposed in the study area. This is the collected field photograph in my study area. This is an asbestos mine, Brahmanapalli, Trivandrum. This is the advertisement Avemla. This is the green pot Veligalu area. This is the pyrobullet near Nilugudu. This is the quartz near Chakrapeta. This is the serpentine near Trivandrum area. This is shaded near Pagadalapalli. This is uranium mine. First comment slide summary and conclusion. Structural mapping of groundwater and mineral exploration using satellite images involves the recording geological information like distribution, identification of rock unit, and occurrences of structural features. The remote sensing image cover a large area in one single view and reflect the characteristics of host rock. In the present study, Landsat 7 ATM plus image is used for mapping the mineral and groundwater resources. It is essential to identify the groundwater potential zone where people suffered from water scarcity. The present study strongly supported remote sensing and geospatial techniques in addition to AHP that ingenious in the identification of groundwater prospect zone in the southwestern part of Andhra Pradesh, India. The weightage overlay model was applied with 8 different influence parameters including dike structure, dike density, linear structure, linear density, geomorphology, geology, land use, land cover, rainfall, slope and elevation. The resultant groundwater potential zone map through JS method and overlay weighted method separated to the study into 5 classes: poor and very good and very good, moderate zone. For validation of the reliability of concluding result, a good inventory survey of the groundwater potential map validated by selecting 130 duck and bore wells by using ACE and the ROC curves with 82% may be conducted on various locations of the study area. Thematic maps for geology, geomorphology were prepared using the Landsat 7 EDM plus image of the YSR district. A geomorphological map is useful to note the elevation of landform features to record the different weathering and erosion conditions in the study area. Geological maps are useful to locate in the host rock of mineral deposits, utilizing their tone, texture, and drainage pattern on satellite imagery. This is useful to determine the stratigraphy of the mapped area, contact of mineral with the host rock, relationship host rock with the inside mineral deposits. The industrialized society rely upon the present study has been taken in the YSR district to prepare an integration map of engineering village hosting in the important mineral deposits along with the mineral content occurring in the concerned village. Get a quick idea of mineral occurrences. YSR district is enriched with several important mineral deposits. Asbestos occur in Lingala, Chinnakudala, Ramanapalli and Brahmanapalli. White pellets occur in Vempalli, Kevalambarpalli, Kottapalli, Vemula, Velpula, Vidipenta, Kevalambarpalli, Veliganda, Ipalla, Loparnapala. Gold, a part of Veligal system belt passes through the Kadapa district. A pyropellet occur in the Surabhi Nilugidu. Quartz occur in the Eragomanapalli and Brahmana Eragudi. Serpentine occur in the Kevalambarpalli, Ganagapalli, Brahmanapalli and Chinnakudala. Stated occur in the Pagadalapalli and Lingala. Uranium, this is the restricted mine. Occur in the Rajkandapalli, Mapindalapalli, Kappalapalli areas of Vempalli Mandal, Vemula Mandal. Thus, the major objective of the study to study the environmental setting of the study area, preparation of various structural thematic layers, prospecting for groundwater potential zone using structural thematic layers, prospecting of new mineralization zone using structural mapping, as well as to mineral and groundwater developer, manager, planner, and researchers in this field. The mandal-wise mineral map of the YSR district with each mineral in such as a map is useful as a reference to government organizations such as Mines and Geology, Atomic Mineral Division, APMDC, etc. And further the private entrepreneurs who are going for the exploration of these mineral deposits. Raising educated questions and answers. The efficiency of structural mapping mineral resource using remote sensing and GIS techniques without checking the ground truth may be elaborately explained by the candidate. He can also throw some light on its validation. We have validated mineral resource map by collecting various ground truth points through GPS at the time of field work and overlaid on the existing mineral resource map, as well as proposed mine resource map in the study area. We found few mines recently started their extraction in the location of which I proposed in my research. Second question, the candidate can explain the role or utility for hyperspectral image studies of remote sensing in mapping of mineral resource and structural control on the groundwater assessment. Hyperspectral imaging is a rapidly developing technology and allows for fast and systematic mineral mapping. Periodically, I have studied about hyperspectral imagery, but the application part I propose to utilize in my future research prospect. These are my publications, various journal. These are the co-author publications. These are the under communication application. Seminars attended international and national. Participation workshop attended. Training and short-term course attended. National and international webinars. Faculty development program. I wish to record my sincere thanks with a profound sense of respect and gratitude to my guide, Dr. K. Raghu Sarkar, Associate Professor, Department of Geology, YB University. The word prone to be insufficient to express my continuous support and motivation throughout the study period. I would like to give my sincere appreciation to Dr. G. Sudarshan Rao Sargaru, Dr. N. Jayaraj Sargaru, Dr. B. Smita Madam, and Dr. S. Srinivas Gaur Sargaru. They constantly ensured the availability of all the required resources for the completion of their thesis. Additionally, they have always provided me with the much needed motivation and reinforcement to enable me to finish this thesis. I am deeply grateful to University Grant Commission providing me NFSC fellowship for financial support for this research. I would like to express my deepest gratitude to Dr. Ajay Kumar and Dr. G. Srinivas for contributing in more than the way in the putting together and the completion of this thesis. Their valuable suggestion and cooperation at various levels of my work have been major factors towards this thesis. I would like to especially thanks to appreciate Dr. M. Rajsekhar, B. Pradeep Kumar, K. Yalamandarao, and G. Mallikarjuna for their constant support through the completion of this thesis. I am also thankful to my co-research scholar, Y. Sudarshan Reddy, Dr. B. Suvarna, C. Krupavati, and Ravi Kumar for being a support and encouragement at every stage of my thesis and for all the cooperation I have received from them. I am also thankful to my classmate Dr. M. Prasad and Dr. R. Siddhiraju for his assistance and help as consistently provided whenever needed. I am also thankful to my class students, all our assistance and help they have consistently provided whenever needed in my field work. I am thankful to everyone they may have intentionally missed out of this acknowledgement, but who has contributed in any little way in giving shape to this work and my thesis through words gesture wishes to otherwise. Thank you.
So the presentation is in over. Now, small interaction with students, faculty, and scholars. So a small interaction with students, faculty, and also scholars. Sir. Small interaction with 5 minutes. Students. My suggestions, suggestions, and doubts.
Thank you, sir. Oral my study area.
Location. Location.
Everybody is everybody data side
scholars, scholars.
without I will get it's not like the other machine.
So now the interaction is over. Now over to Professor Dhananjay Rao garu.
Yeah, I have, because that I have gone through the thesis and all that, I don't have much questions that I have, what my comment that I have put it in there. Only thing is that I just want to ask for the benefit of all the students. Ramchandra,
Sir, yes, sir.
yeah, I just ask you one question for whether you have understood the remote sensing and GIS sections in a detailed manner. Can you just characterize any specific mineral which you have identified and mapped in your area
Yes, sir.
using remote sensing and GIS techniques? Characterize one specific mineral in your area where you have mapped for the using your all these techniques, remote sensing and GIS.
Sir, remote sensing GIS techniques to identify a lineament structure intersection which place intersection that place identified, sir.
No, I just asked you that any specific mineral which you have identified using remote sensing techniques. And if so, you please characterize that mineral.
Sir, I identified structural controlled features, structural controlled and density based identified minerals, sir.
What are those? No, you have identified lineaments,
Yes,
but
sir.
you said that you have mapped for the minerals and all using remote sensing and GIS techniques. What mineral you can identify? Suppose somebody goes your field or other field, so he can say authoritatively that I have identified this specific mineral using remote sensing, and you can also identify, go there and identify using these techniques.
I identified asbestos varieties mines.
Varieties. Then characterize it. How? What is the characterization of the varieties and all? Use remote sensing with remote sensing.
Sir, remote sensing satellite image taken color, tone, texture, and field verification collected latitude values. I suggest to new varieties mine.
You have suggested one new variety varieties area
Sir, Vemula area, sir.
that is already known to everybody, right? Okay, generally, yeah, what I have observed from your thesis and all, You have generally given a statement, that's all, that it is, you have not characterized, you have not identified anything, right? You have just identified some lineaments, and based on that, you said the minerals might be there, right?
Yes, sir.
Okay. Okay, but in your publication, you have to be specific enough that I have identified these are the characters of the minerals and all, and you have to publish like that only. Otherwise, this journal doesn't carry any scope for publications, right?
Okay.
Okay. Anyway, I wish you all the best in your career. Bye. Thank you.
So thank you, sir. Thank you very much for your session, sir. Thank you, sir.
Thank you. Right. Sudarshan, I am done.
Right.
Sir, I am done.
Okay, sir. Okay, sir. Okay. See you, sir.
Right,
Thank you. Thank you very much, sir.
Thank
Sir,
you, thank you,
sir.
Raghu
Thank
Babu.
you.
Yeah.
Sir, thank you very much, sir.
Madam Sunita, sir. Sunita.
Sir, namaste. Very happy to see you, sir. Thank you for your dedication.
Hello?
Hello, sir.
Yeah, anybody speaking?
Yes, sir.
Dr. Sunita, sir. Dr. Sunita, our faculty, sir.
Hussain, sir. Okay. Sunita, madam. Okay. Thank you.
Thank you, sir. Thank you.
Right, madam.
Sir, thank you. Thank you very much, sir.
Thank you, Raghu Babu. Bye.
Thank you very much.
Okay, sir. Raj garu. Bye.
Thank you, sir. Thank you. Many thanks, sir.